Always easy.
Just cover it with some paper.
Class is missing.
You're sitting right here.
I think Mark is. That's who it's on, yeah.
Probably here.
I'm gonna sit right here.
Pull the chair over.
Let's go down a little bit so we don't want room.
Yeah. Got it.
Or here, we're gonna switch chairs. I'll take this one.
Man, I had that chair nice and comfortable.
I'm sorry.
It's all right.
Maybe switch those now.
Nah, it's fine. I can't get these files. I'm playing with brain meter. Downloading things for brain meter.
Okay.
Steve got it, no problem.
We can't get it to work.
Well, the when I downloaded it, that like raindrop button that like installed it, doesn't work.
Good.
Talking about rain meter?
Yeah.
You good tonight?
I don't know. I need to work. Actually, I might just get Rhino installed because I can kind of understand what you're saying.
What do you mean?
Real weird, like.
What you were saying about how working in Rhino for Mac.
I guess when it's.
And popping over Rhino for Windows.
Genius, man.
Certain icons will kind of like.
Like a lot of
It's almost like.
What?
Isn't Rhino for Mac
I
like
don't know what it's called.
I think it has some issue. Well, you know.
Isn't it still a beta?
Yeah, it's still beta. It's still in beta. But, you know, there's just some sort of je ne sais quoi about it that I don't really. I swear, I'm not even kidding. Like, it's not like it'll fail a lot of times. It's just, like, for me, it's going to work.
I don't like AutoCAD for Mac as much as regular.
Yeah, I've heard that's awful.
I like AutoCAD for Mac.
I don't. There's things you can't do in it.
Yes, there
I'm just
are.
trying to get that.
You can do everything.
No, you can't. There are no plot styles or anything like
Yes,
that.
there are.
No, there are.
Yes, there are. I plot them out to them all the time.
Yes, but you cannot adjust your plot style.
Yeah, that was.
No, I even talked to Matt Parker about it. You can't. It's not. And I looked at Autodesk. It's not. It doesn't. It's not a feature on AutoCAD for
Humans
Mac.
are very slow when it comes to adaptation.
No, like you literally cannot go change your color of your plot styles.
Well,
All you
I
can do
never
is
set mine
grayscale and
to colors. I
monochrome.
think it's just-
Yeah, I set them to grayscales and to line weights because it shows a better. Like it shows more dimension.
Steve found a cool one earlier.
What was it?
You're supposed to.
The
Yeah,
whole reason I told you guys about it.
that's exactly what Nick Alt did when he
Yeah,
found
no,
out his
I-
class.
When I find cool ones.
Or Chris Bjorkman, whoever showed when we were in Peter's class. I've always done that. Whoever gave the AutoCAD tutorial.
How do you
Where's your icon?
Never been taught to do that.
Like when Peter gave us those things, they all had a gray scale pointed to them.
Uncheck, show desktop icons. There's still something on desktop that still works.
So you can save your desktop photo?
Yeah, I mean, it's still a directory. It still has things on it.
Okay.
I mean, I rarely click on anything on the desktop to begin with.
Yeah, I have all my desktop.
Alright, so see, what I could do, I guess, I'm going to put it somewhere key, but I just kind of hit command, and you just type in whatever.
Okay, just ignore it.
Sort of like,
Almost like a search key almost?
yeah, like, you see what I'm saying? Like, you just do command and it brings up this.
Oh, yeah. Control.
So that's fine.
That's helpful.
Yeah. I can't remember which one.
Do that like a Windows
If I was
button.
doing structure,
Yeah,
it'd be
yeah.
helpful.
Oh, I have one of those too.
I've had
I don't know.
structure. If I were.
If I were.
Yeah.
Did you?
So it didn't,
No,
it
it's
didn't give you
this weird CFG file, and I downloaded it from here. It gave me the
You should love
zip,
it
and I used it. That,
did you install Rainmeter first?
yeah,
So obviously it's running over there, right?
yeah, I mean,
Alright, we'll get started here in a minute. You guys can load up your pattern family that we were creating last class. If you don't have it, or if you didn't get it to work out, don't worry about it too much. I'm just going to show like one last item to do with that particular curtain wall panel, and then we're going to go into another week. This week we'll be kind of wrapping up the curtain wall panel pattern-based family, so that we can move on to some other topics. But basically, this week we're going to go over how to get a little more deviation and variation, since we can't really utilize that random number formula I keep talking about. I've found some other methods that we can start to get a lot more variation depending on the complexity of the deflection of each one of these surfaces. And this would just be another example of how we can start to utilize just some of the reporting parameters, and then just some of the geometry to actually generate a little more variation in our void openings, and then even the thickness of our particular panel. And this method starts to incorporate, I think you guys all got my email, but it's all going to be based on implementing the adaptive component into the curtain panel family. So we'll get into that, but for now let me close out of this and we'll go into where we left off last class. And I also have a simpler test surface this time, so hopefully cut back on some of our generation time. So when some of you actually made your panel and then applied it to a surface, you probably got something that looked a little more like this, where basically everything that had to do with our void opening kind of got stretched out, and everyone was talking about having some scale issues. And I'm going to go ahead and show you real quick how we can resolve some of those. Remember any of your settings. Remember which file I was in. There you go. So everybody has a family that kind of looks like this. One of the reasons that when you apply a curtain panel family from this environment into your other test surface, and you get something that looks completely different, is because we're always having this panel stretch out to whatever the dimensions are that are on this particular surface. And whenever we build a test surface, you know, we're not really thinking about the size of it, we're just kind of, you know, doing it a little bit free form. And if I tab over, you know, one of these components, I can see that this is a, you know, based on those instance parameters that we set up, I can see that it measures somewhere around 51 feet by 55 feet. And in general, when we're working in our curtain panel families, this is a 10 by 10 grid. So, you know, we're completely always not at a relative scale. All you have to do is think about, if we're going to be applying this to something that's more like 50 by 50, you can select your grid, and if you look off to the left, of course I already set mine to 50 by 50, but your default is something more like 10 foot by 10 foot for the vertical and horizontal spacing. And so if you were to select that grid and then type in 50 foot by 50 foot, you should see kind of that result that you were getting, which had to do with the scalar issues of this void just getting stretched out. Of course, I've already set all my parameters in this one. I need to go back. Give me 1 second. So, yeah,
Does
that-
it affect the parameters of like the radius and I guess things like that when you change the grid like that?
It will affect whatever was referencing your reporting parameters. So all of these dimensions that we put in here off to the left and all the way around the perimeter were reporting parameters that had to deal with where these adaptive points were in relation to the grid. And so any parameter that was referencing, and we named those reporting parameters the T1A and T1B, and T2A and B as well. Anything that references that is going to scale, depending on whatever the size of the grid is. So it shouldn't affect your radius, because your radius will still stay at about 3 inches. So now once we have done that, kind of stretched it out, figured out what our panel size is going to be, and then actually scale our grid up, we can start to see that some of our formulas must not be working out as we had planned. And so this is a good way to test it. And basically all we need to do is change the numbers that have to do with our Calc 1 and Calc 2. Initially we had like a 15 divided by, and we had this formula. And then another one in Calc 2 was a 25 divided by. And we had some other formula, the T2A times C2B divided by 2, just to get a fractional number. If you were just to change your 25, maybe up it to, let's see, get up it to about 1,000 or even 500. Now you basically want to get your Calc 1 and Calc 2 numbers to be something in between 0 and 1. But originally, we'd always been working with something around, maybe like 0.25 and 0.75. So what I just did there got me to 0.39 and 0.78. So if I hit OK, then I get my voids to look like this a little bit. Looks like my triangle flipped on that side. Take them both down to 500. When I had it up to 1,000, this triangle flipped because basically we were greater than 0.5. And if you remember, if you go greater than 0.5 on the line, your dot's going to flip onto the other side. So that's why that triangle flipped. Okay, but the last thing I really wanted to show you on this particular family type is we were going to talk about conditional statements to try to get a little more variation in our form. The one problem, and I'll tell you about this form once we're done with this, we're not going to get a whole lot of variation by the particular way that this one is set up until we start to explore some of these other methods I'm going to present here today. But to let you know, in a formula, the closest we can really get to any kind of scripting without having to get into the whole scripting interface within Revit. And this kind of mimics some things that you could do in Grasshopper with numbers and parameters, but also in scripting, you can get all these conditional statements of if-then, true-false type statements. Basically, in a formula, we can script or write a particular conditional statement to a certain limit. So we can get a little bit more variation, offer a little more choices, but we, obviously are only limited to a few items here. For those of you that don't know what a conditional statement is, conditional statements are if-then statements in a computer programming language. It's basically you're testing a condition. So in this case, we can write a formula. We could say something like, if Calc 1 is greater than 5, then do this particular set of instances. Or if it's not greater than 5, you have another choice and it'll do the false statement. So in the formula, the nomenclature is if you type in if, and then in parentheses, the first item is what you're going to test. So maybe in this case we'll say if calc 1, we'll say is less than 0.5, that's our test formula or our test condition. If you type in a comma, whatever you put in after this next comma is what will happen if that statement is true. So if calc 1 ends up as something less than 0.5, this is what you want to have happen. And so in this case, I might just say, we'll say calc 1 times 2 for now. The next comma after that statement will be whatever is false in that test phrase. So if it doesn't equal the true statement, you have to give it something else to equal. So if it's greater than 0.5, maybe I want it to be always 0.4 as my answer, because remember after 0.5, your dots will cross on that line and go past that halfway point. And if I hit enter, you should see your values for the offset change. You can hit OK. Looks like it just flipped.
You get inconsistent units.
Inconsistent units.
Yeah.
Is your calc 1? Your calc 1 should be a number, right? Should be a decimal value.
It's in
Yeah, you need to make sure you build that parameter. Okay, well, if you have inconsistent units, the thing with formulas in Revit is you have to have the same units. And so when we initially built the calc 1 and calc 2 values, they were set up as a number. So you may have accidentally typed it in as a length, which is the default. So if you happen to have inconsistent units, anytime in a formula, all you have to do is put it in parentheses and divide. That probably won't work. In your calc 1, put it in parentheses and divide it by 1. Dividing anything in Revit by 1 will drop the unit. So if you happen to have length, try that out in the calc 1 and see if that works for you. Anyone else have that issue? Not really? Okay. If you still have any kind of errors that pop up, you might just have to rebuild the calc 1. But essentially, a lot of times in Revit, we'll have to drop the unit. And so anytime we have this issue come up, you just have to divide it by 1. Don't ask me why that drops the unit, but it does. So actually, I'm going to reverse my if-then statement, because I noticed my offset ended up crossing over the 0.5, so I really want it to say if calc 1 is greater than 0.5, make it calc 1 times 2 or the 0.4. The next item is I can take that same formula, if I copy it, and then paste it into offset 2, and I'll change this to relate to calc 2 instead of the calc 1.
When I switch that from greater than to less than, I got a invalid measurement value. The point is no longer hosted on the curve.
Okay.
I just don't know what that means.
That means the point. What did your offset value turn out to be?
1.599.
And so the reason is it went greater than 1, and if you go greater than 1, the point ends up off the line.
Okay.
And I'll tell you how we can fix that in a little bit. Another reason to use conditional statements, basically what I was just trying to do there is get a little bit of variation in the formula so that this offset is equal to a particular set of conditional statements that when we apply it to our new surface, into our model, let me go into that test surface. Hopefully we get a little bit of variation between the different triangles that we've already set up. And of course, I didn't like mine. I think we're going to scrap this curtain wall panel. Another reason to use a conditional statement would be for the problem that you were just having up there, which had to do with your value ending up greater than greater than 1. If you want to have a fail-safe check within your formulas when you've set it up, your offset, you could say if if calc 1 is greater than 1, your true statement, you might want to say, then drop it down to 0.9, and if false, then just make it equal to calc 1. If you had that particular statement, conditional statement in your formula, no matter where you apply this particular component, you'll never have a point that's not hosted on the line.
Is there a way to check for multiple true statements, like an else if?
There's no else ifs. We can do ands and ors, and we can embed conditional statements within conditional statements, but no else ifs, as I'm currently aware of. I'll check into that though, because yeah, that's the whole thing with programming is you can get into the else ifs and then you can check all kinds of conditions. You get a lot more variation that way. If you wanted to continue and embed a couple more choices into this particular conditional statement, wherever you have the true or the false, you could implement another if, and I could say calc. I'm not sure what I'm trying to test here, but I could type in something.
But you can nest them.
Yeah, you can completely nest them, and then you continue on with the, whatever the true would be and the false. I got 2 commas in there. So basically I've nested in the false statement another conditional statement.
Sure.
So you can kind of go as far as you wanted to with the nesting and probably test a bunch of different conditional statements.
I got an arrow. Can make type rectangle something.
Yeah, I think we're going to scrap the this particular curtain panel and trying to get some variation in it just because it works fine for the most case, but when we try to get a little more variation in here, our rules aren't set up. We haven't really thought through all of our rules to make our voids work. Basically what's happening is in some cases as we apply this to a surface, our void is probably going outside of its bounds, and once it goes outside of its bounds, we're getting those error statements. I'm not too happy with this curtain panel anyway because we're referencing a set of formulas or a set of lengths of all of our sides of our particular curtain panel, and these numbers don't really vary a whole lot. If you were to go into your test surface, of course if I were to select one of these panels, I'm in, let's say T2B is at 51 feet for that one. If I go into a next one, I'm at 55 feet. So I'm always going to be kind of equal. And so I'm not going to get a whole lot of variation between the two. And so I'm going to show another method here that we might be able to get a little more deviation. And all we're trying to do here is get a little more randomness or a little bit more deviation to some of our particular curtain wall panels. I'm going to click on whatever your test surface is and change it back to a rectangle form. just so we can get rid of that curtain panel form. I'm going to close everything else in the background. This curtain wall panel, it was a good exercise in learning how to deal with voids, but it's also a good exercise to show you that once we introduce voids into our curtain panels, that's when we start to get a lot of errors if we're not careful. And so we have to be careful about our formulas, you know, making sure that our offsets work correctly and so forth. So I don't need to say that. All right, so we're going to implement a new strategy today and then get into a couple more conditional statements. And this might offer a little bit more modeling abilities too within that curtain wall panel. We need to open up two families. The first one's going to be a new, and we're going to do our curtain panel pattern-based family. And the first thing we're always going to do when we get into one of these families is go ahead and move your points off the grid so we get a little bit of deformation. Then under View, User Interface, go back to Recent Files, and I'm going to open up a new, and this time we're going to go back to the Generic Model Adaptive. If you remember, we played around with that tool a couple weeks ago. We want to go ahead and open that one up, and we can click in the floor plan view for the Generic Model Adaptive family. Let's see if I remember all these steps. Everyone have all of those different families open? Let's go ahead and save each one of them so they have a unique name. I'm going to save the curtain panel family as a curtain panel. We'll call this curtain panel deflection. So I'm naming the curtain panel and I always put in class in front of mine, but I've got in class curtain panel deflection. Then I'm going to go to switch the windows at the very top, and I'm going to switch into my other family. It should say family 2, or yeah, it should say family 2. Now I'm going to save this one, which happens to be an adaptive component. I'll call this one in class adaptive deflection. Everyone got that part? Back in your curtain panel family, we're going to draw a reference line with our 3D snapping on from one corner of your panel to the other. So basically making your die grid. And then, once you've done that, let's select just the triangle. Doesn't matter which side, just one of the sides. And create a form, and we can just create a surface form. You should just select that second thumbnail. We don't want to extrude it, we just want it to be flat. Go ahead and hit save as much as you can. I crashed my computer a couple times last night doing this. Everyone got that? Okay, the next thing we're going to do is select that surface so it's highlighted as a form element and it's blue. And once you do that, if you look over to your properties to the left, you see everything in the family environment will always have a visible checkbox. I'm going to go ahead and uncheck that. And you'll notice that nothing really happens on the screen, except that every time you select this particular element, you should see that your visible checkbox is unchecked. This is where we start to get into what's known as using objects as construction objects to report other information for us without having to have it show up in a model once we basically load it into another family type or a family environment. If you uncheck any element that's been created and you uncheck it as visible, whenever we load this into the next project, whether it's another family type or whatever, you will not see that triangle. See the next thing I want to do is whatever point is opposite of your triangle. So you see this other adaptive point that's off to either the right or left, depending on how you have your screen. We want to draw 2 point elements that are associated. So you want to pick the horizontal plane of that adaptive point.
This is in model, not reference.
Whenever you do a point element, it should always end up as a reference point. And I'm going to draw 1 point and turn on its reference planes. And it doesn't matter where that point exists. You're going to just have to place it somewhere. But we ideally want it to align and be locked to this point. And so using the align tool, you're first going to pick one of these vertical planes of the adaptive point, the one that's on the reference lines, and then select the corresponding vertical reference plane of the reference point you just placed. Once you do that, click on the padlock, and then you're going to do that same alignment in the other direction. So then select the other perpendicular plane of each one and hit lock. So basically you're aligning that point directly on top of the adaptive point. Do I need to back up? Everyone get that?
So it's basically 2 points on the same spot?
Yeah,
Okay.
at this particular moment.
Do you mind redoing it? Sorry.
So if you've placed your point, the alignment, and you guys really want to get this alignment tool down because we're going to use it a lot even when we're in the project environment, is you're first going to click what you want to align to. And so we want to align to one of these planes, vertical planes of that adaptive point. And then the next item that you select is the form element or the reference plane that you want to actually move to be aligned with the adaptive point. And once you do that, you'll get a padlock. You want to lock it, and then do the alignment in the other direction. Then you can select that point, and over in your properties, we want to change the offset to something like 200 feet. Just make it a very large number. And it should go way off into space if you zoom out. Do that same set of steps, but the next point you want to offset at negative 200 feet. So again, I'm going to select point element, pick a reference plane. I want to pick that horizontal plane of the adaptive point. Place my point somewhere. Select the point, turn on its reference grid or planes, and then align it to that same point, locking it each time. Then the last step should be change your offset on that one to be negative 200 feet. Oops. So you should have these 2 points that are way off into space. The next step is we want to draw a vertical line that connects both of those points that you just placed. And this line will actually be a model line and not a reference line. And so you need to turn on 3D snapping, and then it'll allow you to snap to each one of those points. Once you've done that, I'm going to select the model line, and we're also going to turn off its visibility. And it should kind of gray out, so it's kind of hard to see up on the screen now because of the gray background. But basically, any model element that gets grayed out is showing you that when you actually load that into a project, that's the items that aren't going to show up. You would think the surface would have done the same thing, but for some reason surfaces do not. So that gets kind of confusing.
Should that be one single line or should it be split in two?
One single line. So if you just do a model line and you connect from one point to the other, it should be one. You may have done a reference line if you got it split. Everyone there?
What did you do to the line?
After you placed the line, I selected it and then turned off the visibility.
Right, I have them locked together.
Because when you lock them, it should move it.
It didn't, yeah, I didn't move it though. I got them.
So use your align tool and make sure you get. Yeah, they're already on the same plane on that plane, so you want the vertical plane.
Okay.
You're selecting the horizontal.
Okay.
There you go. And then lock that. Make sure you lock it. And then do the same thing with the other plane. The vertical.
Sorry, I didn't know that one. So,
You want to always pick this one first. And then lock it. And then use your modify tool, which is right to the top left. Top left. Select it and then make it offset 200 feet up in your properties. And then you would do the same thing with the other point, make it negative 200 feet. Because you constrained it to the horizontal. You don't want to do that because you want it to move up. Alright.
Yeah, I can't get my line.
What?
It moves my around 200 feet.
Move it 200 feet down.
Yeah.
Say like just maybe 200.
This is first.
is what you want to align to.
I mean, I assume, just from what I heard.
That line is
Yeah,
That
so
one, just leave that one in there.
So you mean.
So that's one thing I'm gonna do, when you do that point, so delete that real quick.
oh, I didn't pick it.
Yeah, you gotta pick that horizontal line.
So the point you just
The first
aligned.
class.
Yeah.
See, that's why I got really confused.
Yeah.
So I took the horizontal.
Turn off your thick line.
So now I do the line.
Yeah. No, I use the line.
I just do this, okay.
He's gonna come
So
back
I
and
do
say,
those two.
Just click.
He's gonna be like a marker mark, you
For
know?
those two.
I don't see that wolf looking. Look at that wolf.
I'm gonna need to get back like that, so. You did get this one.
I mean, maybe that's
I don't
the-
like it, Carson, but I got it. This one.
Okay, and then you
Just a
just,
regular one.
so like you just drew a line from here to here?
Yep. And then, you want to click on the line. Make it just.
Oh my gosh, there you go. I am struggling today. I'm so tired. I'm just gonna give it a
Behind.
It was that stupid 3D snapping. I was like, why will my record not work right now?
That I got.
Like an idiot.
So you always want to do the, I don't know what I align to first.
Yeah, there's.
You lock it through that page.
I've got too much repeat.
Clint, did you like that one? Panda and the Slanky.
Okay. The reason I've set all of this up is that essentially this is a construction triangle and a construction line that we're going to use to measure deviation or deflection. Basically, everything that we're trying to do to actually get a, to know what the deflection is of a surface, when we apply it to another complex surface, can be measured along this vertical line because it's reference based off of this horizontal. All right. And since we've already kind of kinked our rectangular reference plane, so it's already got some form of deflection to it, once we place a line, we will, we're actually going to place a point on this line, have it hosted by the intersection of this surface to the grid. And that will measure the actual deflection, and it'll kind of make sense in a minute. It's hard to explain just off the top of the head here. If you just place a point element, and make sure you place it just somewhere on the vertical line. Once you do that, you can select that point, and notice that whenever you select a point that's been hosted on an element, you have this other option up here on this green bar that says host point by intersection. If we select that host point by intersection, it wants you to pick a face to define the host intersection with given curve for the point. So basically all that's asking you to do is select that surface that's already in this model. So I'm going to select that form element that we've created, and you should see that your point drops down, or it might move up. It'll move in some direction. The other thing we want to do is select that point and also turn on the show reference plane always, and then uncheck your show normal so that you can see all the different planes that are associated with it. Now, take the point that's opposite of this triangle, or at the end of this triangle, opposite of that point, and just drag it up and down, and watch what happens with the point on that model line. you should see that the more you deflect or deviate from the zero plane, the further that point goes up and down the model line.
Jeremy, what was the option for that host?
Once you have the point, if you click on it, there's a point up there that says host by intersection. And then the last step you want to do is turn on all your reference planes and uncheck the show normal. Everyone get that to work? So this is a little more exciting because when we actually apply this to a curvature or a form that's actually curving, we should get a lot more variation in the deflection of each of the panels from one point to the other across the surface. But the last step that we want to do, because we've only used all of these different construction lines, is we want to actually flip into our adaptive point or our adaptive family. So I'm going to switch over to I called it in-class adaptive deflection. And if you're in your floor plan view of that, we're going to place 5 point elements. The first 4 kind of make a square, and then somewhere off to the side, place your fifth point. We want to select all of those points and make them adaptive. So once you select them all, you should have the option at the top that says make adaptive. I'm actually going to move my 5th point near my 4th point, just so I can keep track of it.
Does it matter what order we drew them in?
Ideally, you'd be, it doesn't matter just as long as you've got 1, 2, 3, 4 kind of going around the square, and then your 5th point is somewhere near the number 4. I'm going to flip back into a 3D view in that same file. And now draw a reference line that's a chain that only connects, and make sure you're snapping to each of the points. You should get a little point icon that pops up. I'm going to draw from 1, 2, 3, 4, and then back to 1. Hit escape when you're done. And then I'm going to select all of those reference lines I just drew, and we're going to create a solid form and make it so that it has an extrusion to it. Just like we've done before, I'm going to set up a, let's call it a thickness parameter. And it will need to be an instance. And for now, I'm just going to type in like 1 inch. And you should be able to select your form element. You want to make sure you highlight the whole entire thing. You may have to tab over it a couple times. And then you get the positive and negative offset in the properties. We'll make that equal to the thickness parameter. It's always good to have some kind of thickness to all of our planes that we're going to deal with. We're going to draw another reference line, and this time it needs to connect to the number 4 and the number 5 dot. And again, make sure you're snapping to the points.
The lines to create this form, were they supposed to be referenced as well, or were they model lines?
Yeah, everything was supposed to be referenced.
We should redo that.
Looks like they're already referenced.
I guess they are.
Yeah, they're good. If you didn't do them as a reference, you wouldn't have that option off to the left to do the positive and negative offset.
Oh, okay.
So if you ever happen to draw a solid and you don't know why you can't do that, it's probably because you drew them as model lines. All right, the last step so far on this, I guess we can call it a kite. So we're going to draw a reporting, we're going to create a reporting dimension that reports the length of the line between 4 and 5, that reference line off to the side, the little tail. So I'm going to create a parameter. This needs to be instance reporting, and let's call this deflection. Now remember, when we start to dimension in these adaptive components in the curtain wall or the curtain panels, when we select the dimension tool, we need to make sure we set the work plane. So off to the left, you can hit set, and then we're going to hover over that reference line that we want to measure. And then we want to measure from the adaptive point. We want to make sure you tab over until you get to the next adaptive point. If you don't measure to the adaptive points and you actually are dimensioning to like the form element or the vertex, we'll probably get errors later on. Then once you have that, you can make that dimension equal to your deflection parameter. So change your label to deflection. Let's go ahead and load that into, you want it to be loaded into your curtain wall panel. And then it's going to ask you to start placing the points because we've loaded this adaptive component into the family and now it wants you to place it. What we want to do is make sure we snap to each of the corners of the adaptive curtain panel. I think I did mine backwards. So you want to do it in the order. I have to go back to my item here. That fourth point needs to be, the fifth point is going to be the actual point that's on the model line that moves up and down. So I actually want 1, 2, 3, 4, 5, there we go. So since I canceled out of that command, I can just go to Home and Component, and then I can select my adaptive component again. So I'm going to select this point, then the next one, the third one, the fourth one, and the fifth one will be the point on that vertical line. So when you select your form that you've just placed, you should be able to select it, and it should also report the deflection is, in my case, 3 foot 8 inches. If I were to take this number 2 point and move it again, you should be able to select your form and also see the numbers change. So now I've got a deflection of something like 8 foot. Everyone got that reporting? Cool, catch up after. I'm gonna switch now into a test surface. So if you don't have one open, make something kind of like this, and I'm not gonna divide it up as much as I normally do, just to hopefully save some time. And we should be able to take our curtain panel, and we're going to load that into your test surface and apply it. Let it think for a minute. So now when you look at your individual components, and right now it should just be kind of a series of solid surfaces because that's all we've created so far. If you were to tab over and select one of the panels, for instance, this particular panel reads a deflection of 17 feet. If I go to the next one over, that one's 30 feet. The next one over is 92 feet, 29 feet. So basically what I'm getting is a lot more variation from one panel to the other by measuring the deflection of the surface.
What is the deflection measuring from? Is it the center of the panel to the corner?
It is measuring from the surface normal of the panel. So whatever that plane is, it should be measuring from there, and then a surface normal perpendicular to a horizontal plane. So actually, if you were to go back into your curtain wall panel and click on that line, and then click on visible, and let's load that back into our test surface. We should get all these lines that are shooting off into space. That's showing you basically where the horizontal plane is perpendicular to that line, and that it's going to be measuring some deflection or some distance off from one of those corner points. It's basically measuring from this point that's across the way. That's the distance of the deflection. So if I were to move this point that's opposite, closer to the grid, you should see that your deflection point moves closer to the grid as well. So it's really the plane, it's actually the measuring from the plane of that construction triangle is what it's doing. Because you can move any of these points and you'll get a deflection.
Is there a way to check if the recording parameter is working or not?
If the what?
Is the recording parameter is working or not? I don't know if mine is.
Yeah, you should be able to, let me go back to my, if you're in your curtain wall panel, you should be able to select on that adaptive component that you placed in there, and it should report off to the left the deflection value.
Oh.
And if you move your points around to get a different deflection and then select that surface again, you should see another result. If for some reason you're seeing the same number and it's not changing, that means something's not snapped correctly to your adaptive component. And so same thing if you're in your test surface. Oops, I need to. You can tab over each individual panel, and you should also get a readout off to the left what the deflection is. All right. So let's do something very simple. And basically what we've just done here is a random number hack in a way. Because Revit doesn't have the random number formula, which would just make things a lot easier, we have to find a way to get as much variation as we can from one panel to the other so that we can get a form of randomness across a surface. It's still going to be kind of similar from one point to the other, but the more you actually deviate your form, so if all your deflection values are kind of similar, that's probably because you're close to a horizontal plane when you're going across your surface. So if you start to make your surface a little more extreme, you should start getting even more extreme numbers from panel to panel. So a real simple way to get a little bit of variation would be to go back into our adaptive component. What we've done here with the adaptive component is we're mimicking what the curtain panel pattern-based family does. You know, basically we drew our four corners, we made a square, that's all reference points, and of course we have a little tail off to the side that we won't really worry about. But everything that we've ever done with the curtain panel patterns in that other family type, we can also do here to create the shape. So we're going to start using this as our actual curtain panel family, even though it's really an adaptive component. So try to keep that straight if you can. The reason for that is once we're going to build all of the parameters within this particular form. So far we have a deflection parameter and a thickness. To get some variation just real quick, why don't we just make the thickness equal to the deflection? So type in deflection in the formula. We can save that. And then we're going to load that into...
I'm getting an error.
Me too.
What's your error?
It says a reporting parameter can be used in a formula only if its dimension references are all to host elements in a family.
So that error is one that we'll probably get often. How many of you got that error? Okay, half the class. All right. First of all, make sure both of your parameters are thickness and deflection. One should say report, the other one says default. Is that correct?
Yeah.
Okay. The next item would be that your deflection, remember I said you have to make sure that you snap to the adaptive points. If you happen to snap to a different point element, and when I need to rebuild that. When I rebuild this dimension, and if I hit set, I'm setting it to this plane. When you especially go over to this point number 4, look down at the very bottom and make sure that you are tabbing over until it says adaptive point placement point 4. And you should have the other one say 5. If for some reason you snap to a different point, that should be the reason for the error. So now if you load that into your current panel and overwrite the existing version, and then we're going to load that into our test surface, and you always want to overwrite, and then you'll get another one because we are starting to nest families within another one. It'll say, do you want to overwrite the shared component? You always want to select the one that's in the option in the middle. It says overwrite the shared subcomponent family and its parameter values with the, and it will give you the name of your file. And so, depending on how many different surface forms you have, or different panels that are divided up, or your complexity of your form, you should get some variation within your thicknesses across the surface.
That's telling me that it says an instance parameter can't be used in the type parameter formulas.
So back in your adaptive point where you're setting those parameters, you have to make sure that thickness, when you click on modify, it should be an instance parameter. And that should solve the problem. Because remember, whenever you're using formulas and any kind of reporting dimension is a instance parameter. So all of your formulas will have to have parameters that are instance based. All right, so
Is there a reason we couldn't do all of this in the certain panel?
yes, because you need that adaptive leg. You need that second leg as a form element. Remember that error that everyone just got that said you cannot use reporting parameters unless it's hosting some object? Well, if you were to go back into your curtain panel, and instead of using that adaptive component, and if you were to actually take a dimension from here to here, it's not referencing, it's not on a reference of this curtain wall panel boundary, and so it's outside of the host, and you'll get that error every time that says you have to be hosting some form element within in that family in order to use the reporting dimension or the reporting parameter. So basically, we've had to do kind of two types of hacks. One was to get some randomness to it. The other was to get some element that's actually a reference plane associated with these 2 points that we can actually dimension. Up my divisions a little bit. Now in your curtain wall panel, another item that you could think about doing is using, get this update, is using that point that moves up and down the model line we could actually use that as another point to create your solid surface. And so you could actually have a solid surface that would have fins that would kind of move up and down along with that point. So you can start thinking about hosting various points along model lines that can move up and down in a particular direction based on deflection. And you could start to, kind of rotate all of these surface panels up and down depending on the different deflections of the surface. We'll try to do that next class. One last thing. So then obviously if we have our thicknesses, and I've got some pretty extreme, volumes along my surface, this is where you would want to probably go back in and adjust your formula. So right now we're always equaling whatever the deflection is. Maybe you actually want to just change that to a smaller number, like deflection divided by 100 or even 50. So that whenever you're in that test surface, you can cut down on the extreme nature of the thickness. So basically all your formulas within that adaptive component are really going to be dealing with scalar type of issues. Okay, the last thing we're going to do, and we have about, 10 minutes here, so we should be able to do this, is I'm going to go back into the adaptive component, because this is where we're going to be building everything from now on. I'm going to turn on the wireframe mode, and we're basically going to make a void that we can cut out that should change its aperture size based on this deflection value as well.
Did you change your thickness setting for deflection?
Yeah, I'd gone back in my formula for the thickness. I changed it from, I did deflection divided by 50 for now. So now I'm going to draw some point elements that will be referenced on, you're gonna have to zoom in a little bit, on one of the reference lines. We want 2 points kind of near each end, and we're only going to do that across, basically 2 parallel reference lines. So it doesn't matter which side you're doing them on, just as long as you've got a point next to each end, and then off to the other line that is close to parallel, or should be parallel, that we're going to go ahead and draw 2 more lines that are going to be hosted on that reference plane. Just set up 2 parameters, one called, just call it point 1, and it needs to be an instance, and it needs to be a number. The other one will be point 1 inverse, and again a number, an instance. The formula in the inverse parameter will be 1 minus PT1, or whatever you called your point. We might as well set PT1 to be, we'll just set it to 0.25 for now. And then we can select each of these lines that we just hosted on a reference plane and change your normalized curve parameter to be closest to whatever, like right now I selected this one as 0.8, so I'll make that my 0.1 inverse. And the other one should be just the 0.1.
Where did you change that?
What's the question?
Where did you change the RM? Before you started assigning it?
So I've got 0.1 as 0.25. 0.1 inverse is a formula, 1 minus 0.1. Then I selected one of the points that are on the reference line, and you should be able to select the button that's in the, if I expand this, it's called normalized curve parameter, part of the properties. And if it's greater than 0.5, you want it equal to your inverse parameter. If it's less than 0.5, you would make it equal to the 0.1 parameter. And do that on both sides. Then draw a reference line that would connect one side to the other, and make sure your 3D snapping's on and all that fun stuff. And you might get an error, or a warning that said something about my line was slightly off axis. Don't really care. I'm kind of showing you guys a quick way to make a void. Last time we had to make a whole bunch of other additional points, maybe because we're working with triangles in the die grid. But essentially, once you do that, if you were to test out your point, maybe change it to 0.3, your reference line should also move. Then on those reference lines that we just placed in the middle, crossing from one side to the other, just go ahead and place 2 points on each of those and assign them the same values of, if it's less than 0.5, make one of those 0.1, the other one the 0.1 inverse. And then your last step is to draw reference lines that connect those points. So basically we're just trying to make a square in the center. And we'll also have to draw, sorry, undo that. When you draw that reference line, make sure you have chain selected, and we actually want to trace all 4 corners so that we're actually making a square within or connecting all those points. Last step is to create a void. We always want to make sure it's greater than our thickness of our element. So I'm going to make another parameter, call it void offset. It needs to be an instance. And that one will have a formula thickness. We just say thickness times 6 to make sure it. And then you can actually select your square in the middle, create a form called void form. Select the thumbnail off to the left, and then adjust your positive and negative offsets to be your void offset dimension. That will always ensure, no matter what the thickness of your particular component is, you'll always have your void cutting through it. We can load that into the curtain panel, and then load that into your test surface. That's pretty much all we're going to have for today. That's why we're going to take Thursday as well. I think I emailed you guys a schedule where I'm updating the syllabus a little bit. We're going to take this a couple steps further on Thursday by actually making it so that these void openings can open and shut with a little more variation. And then also we can add a material such as a piece of glass within the void. And we can also make it so that our colors or materials change based on deflection as well. What I want you guys to do for Thursday is to make sure you can have this working. So if you didn't complete this in class, make sure you have it completed. And can everyone stay for 1 minute? I want you guys to do a little bit of research online or in any kind of books you might have that has to do with working with complex forms. And I'm showing a couple images at the top. But once we get into working with complex forms and all of these different shapes and complex surfaces that curve in various directions, and we start to apply some sort of structural element to it, oftentimes designers will look towards patterns that you can find in nature, patterns that you can find. Is this something you guys have done before?
It's a Wayne's thesis.
Is that you? Okay. So anyway, you might talk to Wynn there. But there's looking at forms in nature, whether it's at a microscopic level, or just looking at patterns throughout, whether it's in what other architects have done, or other digital architects who maybe some of these components have never been built, but you might find some renderings online. I want you to think about a pattern that you would like to actually implement into your final project or this midterm project, because all of this is going to eventually get applied to your funky foam surface. So start thinking about a particular pattern. I want you to produce a 11 by 17 slide. When I say 11 by 17, I mean if you go into InDesign and set your paper to 11 by 17 landscape, and just put down your ideas of what you're thinking you would like to build, and have that uploaded to the class website on Thursday. I'm not going to hold you to you have to build it exactly like that, but I want to see what you guys are interested in, so that we can make sure we can maybe have a couple tutorial sessions of trying to tackle some of those items. Okay? I'll stick around for questions. You have multiple surfaces there?
Yeah.
Okay. Yeah, that's good. Where'd you get it?
Well, I got it, I ended up finding, I think what I tried to do is when I loaded it in, I need just, like, when I find the basic stuff to do, like I selected. But then I don't.
When you did the adaptive fusion, this is your piece that's going to be hidden.
Oh,
That's that
how do I
one.
kind of?
Or when you select it, you need to make sure it's just check visible. It's not going to hide. It's not going to hide there, but when you load it into the next.
Where I got copies my sign.
So this is
When I
one,
pulled
this
these
is
in,
that's one.
Well, it goes like
so
this, it's like-
it was placed on
think of it
face,
as a
right?
line like that, so this
And
one-
I went around and I selected the 1, 2, 3, 4, 5. Okay, then I got it.
So you want to start here.
Yeah.
I need to put it on
That's what I ended up doing, so it should be,
Got it.
so this is what happens.
Yeah, I saw that, I just,
That thing. That should be visible, so that's
So when you look at it,
Probably the reason
now,
you
that
didn't
should
share
go
when you
away.
tried it is because you were coming into